Good afternoon, sir.
Today we will be starting another case of TP called assignment problem. We are starting assignment problem. And the assignment problem is such. Little different from that of TP. For instance, in transportation problem, we have allocation of units. We have allocation of units. What does it mean? Number of units to be transported from origin to destination. Whether it is balanced or unbalanced, optimum. Same algorithm, but in a different situation. And that is called assignment problem. AP. It is called AP. Attentive all of you. How to introduce AP? Okay. There are 4 workers. A simple example first. This example is not in your question sheet. In question sheet, examples are different. There are 4 workers and 4 machines. The data is time. In minutes to complete a task. For example, assemble a product. 35 minutes to assemble a product by worker 1 on M1. Same worker take 29 minutes on M2. 26 minutes on M3. 25 minutes on M4. Similarly, worker 2, worker 3, worker 4. This is the experienced data by workers on machines. This is the experienced data by the workers on different machines. Now they are working on a same shift. the production manager wants to assign the workers to the machines such a way total time taken by them is minimum. Total time taken by them is minimum. Clear the introduction?
Yes, sir.
For example, worker 1 get M3. Now how many choices worker 2 has?
3 choices, sir.
3. If he get M1, then worker 3 has how many choices? 2. So 4 into 3 into 2 into 1 is the permutation combination for all the possibility, of which 1 gives minimum. So mathematically we say if the worker is assigned to machine 1, then the score is 1. And for other machines, score is 0. For example, if the worker 1 assigned to M1, then the score is 1. And how much is the score for M2, M3, M4?
0, sir.
0. So what is the row total?
1 only, sir.
What is the column total?
Again 1, sir.
But very good. Therefore, in assignment problem, the row total and column totals are always 1, which is not the case in PP. Which is not the case of transportation problem. Now, directly you work as your solver. I want the minimum total transportation product, that is the time on the machine matrix multiplied by the allocation matrix, assignment matrix. I have the row total 1. I have the column total 1. Where is this 1? Solver will decide. Data, go to solver, reset all. Reset all. My cell will be U3. I want the minimum. My assignment matrix will be zeros. And the constraints are all these row constraints and column constraints equal to 1. Solve it. How many minutes they take? How much total time it will take to complete 4 tasks?
105.
105.
So within 105 minutes, 4 of them complete 4 units. A day they work 8 hours, so how many units 4 of them complete? Eight hours means 480 minutes, correct na? So how much time it will take for them? How much time? This is equal to 105 minutes multiplied by 480 minutes divided by 4 on an average. 12,600 units they complete in a shift. Approximately. Four units are completed in 105 minutes. So 480 minutes, how much? That is what I have shown to you. So worker will get M1, M4, worker 2 will get M1, worker 3 will get M3, and worker 4 will get 1. And this is a balanced AP because number of rows equal to number of columns. Number of rows same as number of columns. Any question on this?
Sir, can you again explain the 4 metric part?
Which part?
Sir, how did we get the figure 12,600?
Solution.
Yes, sir.
Just like our TP. There we have allocations. Here we have assignment. So my initial metrics for assignment will be zeros.
No, sir, I was asking what was the 12,600 part? Like 105 were the minutes, right?
Yeah. How many they complete in 105 minutes? How many units they complete in 105 minutes?
4 units.
4. A shift has how many hours?
8 hours.
How many minutes?
480.
So 105 they complete 4. So 480 how much? So answer will be 480.
Sir,
What
shouldn't
is
it be?
Multiply by 4 divided by 105. Approximately 19 units they can complete. Is it okay? Approximately 19.
Yes, sir. Yes.
This is simply a hypothetical figure because we are projecting based on one assignment. Suppose if the machine slow down, number can reduce. If the machine break down, number can reduce. If the machine is replaced immediately, then there won't be any problem. So this type of work we call assignment problem. Any other question? Okay. Suppose 35. Suppose in a particular example, 35 units will be completed in an hour. 29 units are completed in an hour, and so on. Data tells you the number of units completed by the worker on the machine. Then what should be my objective?
Maximize, sir.
Maximize. So, remaining all algorithms remain the same. We go for maximization and get the work done. Now, how many units they can complete in 1 hour? Four of them together complete how many units?
126.
8 hours how much? Multiplied by?
8.
Finished. So the estimated number, that is 126 multiplied by 8, will give you a rough idea whether they meet the requirement for the market. Such plenty shifts are there. Sorry, plenty workers are there. So all this depends on efficiency of the worker as well as the machine condition. So we found out there is no change in my algorithm. There is no change in my algorithm. Algorithm still remain the same as transportation problem. It won't go. But the problem is situation is different. The problem situation is different. Okay. Suppose worker 3 is not going to assign M2 and we want the minimum time. What is to be done?
We will increase the number of minutes taken by that.
Correct. So give a large number minutes. Now let us see the allocations. Again 105 minutes and the worker will never get on M2. And say for example, worker 2 is not assigning M1. Now,
I'm sorry, sir. So could you please repeat that?
yeah. Conditional assignment. We were working conditional assignment like transportation problem in the last class. What did I say? I want the minimum completion time. And I don't want to assign the work W1 to say M4. So if I assign here large number, I will not get the assignment. So how many minutes it will take? Now how many minutes it will take to complete the task?
108.
So which is actually we have repeated. Ulta, if these are the products to be manufactured in an hour, then problem is maximization. And in maximization problem, we have seen it comes out to be a number which is maximum 126. And worker 1 will get M1. Worker 2 will get M2. Suppose worker 3, we are not going to assign to M4. Then what shall I do? For that, what shall we do?
Decrease the number of units produced.
Decreased. That means I will give this as a negative number. Now let us see what is the final. How much now total production? 125 units. Is it W3 gets M4? No. So what we had was a repetition of TP only. We have a repetition of TP only. But the allocations are not there, assignments are there. Any question here? Okay. Suppose if there are 3 workers only in the shift, 1 absent, but the machines are 4. So what sort of assignment problem is this? What sort of
Unbalanced.
unbalanced assignment problem? So one machine will be idle. So how shall I make it a balanced assignment problem? Introduce a dummy worker with 0, 0, 0 as the data value. That is what we have done in TP also. In TP also we have done the same thing. Therefore, this assignment problem is actually a repetition of what we have done. But here specifically we don't have any meaning of northwest corner method, least cost entry method or one. Directly we can go for assignments. Any question? On one problem on the screen, I have shown you all the cases For example, see the unbalanced one. There are 5 types of dresses to be stitched. Tailors are only 4. Tailors are only 4. Dresses are 5. So if I want to know which dress to which tailor, I have to convert it into balanced. Apply the algorithms and solver. You can see D3 will be not having the tailor. Because D3 is assigned to T5 and T5 is a dummy tailor. So the balanced unbalanced concept, which already we had introduced in TP, is exactly same in AP. Whether it is balanced or unbalanced, you have to proceed with the proper algorithms. That is what these 2 questions shows you. It is shown mathematically on your sheet. This is your linear combination of data matrix and the allocation matrix. C stands for cost, X stands for allocation for ith row and jth column. And this is what I have shown to you. Row totals 1, column totals 1. What is 1? 1 if the worker is assigned to jth job. 0 otherwise. This is mathematical modeling for solver. Now all of you start working on question number 1. Now I will not do. Do this question number 1. A small matrix 3 by 3. Both you have to do, minimum as well as maximum. Everybody has to work. Rahul Ghosh,
Yes, sir.
are you working on the example?
Yes, sir.
Pitanjal Datta,
Yes, sir.
are you working on the example?
Yes, sir. I'm trying. Yes, sir.
Whatever time you want, you take it, but everybody has to work. Rishabh Kotari,
Yes, sir.
are you working on the example?
Yes, sir.
Remember, after 20th, you have exam periodic 3, completely operations research. And final will be March 8. That is not MCQ, definitely not. Actual question paper. Theory as well as real data work. Both statistics and operations research. Vineet Sharma. Sujit Kumar.
Sir, what's the answer?
Yeah, wait. Let everybody complete first. How much you got, Ali Sagar?
Sir, I got 21
Ali
and
Akbar.
26.
21 and 26.
Yes, sir. Yes, sir. I got same.
Yes. Yes. So for 21, worker will be which machine?
Sir, 1 will go to 3, 2 to 2, and 3 to 1.
Yes. And for maximum?
Sorry, sir, I
For
told you the
maximum?
maximum. What I said was for the maximum, sir.
What is for minimum?
So for minimum, worker 1 will go to machine 1, 2 to machine 2, and 3 to machine 3.
Yes. Those who are completed, start second question. I can wait for others also. Verify the answer 21 and 26 and then go for example 2. Gaurav Datir. Gaurav Datir. Can you hear me, Gaurav Datir? Yeah. Could you complete question number 1? Okay. Do second one. Setu Sharan.
Yes, sir.
Could you complete first one?
Yes, sir.
Do second.
Okay, sir.
Second question first everybody should do for minimum and then go for the maximum question.
So for minimum, I am getting 42.
Yes. And assignments S1 to be
Sir, 2.
S2,
Sir, S2 to 4,
S3.
S3 to 3, and S4 to 1.
Perfect. And maximum
So maximum I am getting 54,
S1 for
3,
S2 for
1,
S3 for
2, and S4 for 1.
correct. Now answer the question number 1 and 2. Who gave me the answer? Who was the answer given me now?
Sir,
What's your
Akash.
name?
Akash.
Please type the answer in the chat box.
Sir, are we supposed to solve question 3 as well?
If you have completed 2, start 3.
Okay, sir.
Akash Singh, what is the answer for question number 1?
Sir, we got 21 for minimum time and
And-
26 for maximum unit.
Yes. S2 is not assigned to section 3. That is this number. And problem is maximization. So what is to be done there? Sakrikar. Setu Sharan. Setu Sharan. Mihir Sakrikar.
Sir, I'm doing it. I didn't get the answer yet, sir.
Okay. Sarvesh Bagal. How much is the answer for the first? Sarvesh Bagal, type your answer for first one. S2 is not assigned to the S2 is not assigned to 3. S2 is not assigned to section 3. So what is to be done? Okay, solve it.
So for question 3, what's the answer?
Yeah. Question 3. एक second. Which machine is idle?
Sir, I'm getting number 4 is idle.
That is Z.
Yes, sir. The last one.
Okay, what is the time?
50.
Okay. Good.
So I'm getting 64.
Is it minimum?
Maximum.
No. Question is minimum now. For example, 3.
Okay, sir. Sorry, sir. Yes, sir. Got it.
Yeah. Akash Singh, type the answer of 1 and 2 of question 2. Let everybody see it. Avani Mishra,
Yes, sir.
could you complete all the three?
No, sir, I'm doing it.
Okay. I'm not in a hurry. I can wait. Let everybody complete the examples.
Sir, I have a doubt.
Yes.
Right now, what we are doing in the solver is we are assigning a fixed value as a constraint. Now, can
Yes.
there be any events where the constraint itself is a formula?
Constraint itself is a formula. Then you have to generate the data and then give.
As in, sir?
Then you can give.
No, sir. My question is like, suppose the constraint themselves were changing as the allocation in the table changes. So will solver
Yeah,
be
but
able to
it
do
should
that?
not be formal. It should not be a functional form.
Sir, I do not understand what you meant by a function.
Suppose fx is equal to x square.
Okay.
So you cannot give x square to the solver. But
Because
if
it will
x
go
is
in a
equal
loop.
to 3, 9, if x is equal to 10, it is 100. So that way in a column numbers to be generated and give.
So then the constraint has to be a fixed number only.
Yeah.
So it cannot
Range
be a
of
dynamic
numbers,
change.
range of the data.
Range of data.
Uh,
Okay. But it cannot be a it cannot be a
Function
dynamic form of data.
function nahi. Because what happened if you give function, what will you give to the right hand side equal to? Correct, na?
But so what if
If
that
the
cell itself contains a formula?
they see when we are giving the wait a minute, I will show you. See, when we give the constants, we have a left hand side, we have a right hand side, correct na?
Yes, sir, correct.
Ali.
Correct, yes, sir.
But if I give a formula here x square, wait a second. If I give a formula x square, then what shall I do for right hand side?
No, sir.
So what?
No, sir. I think you misunderstood me. This can be, so where you've written x square, that will be a normal variable, sum of x, y, z, right?
नहीं function है अभी तो formula है.
No, so वही बोल रहा हूँ यहाँ पे जैसे हम solve करते आए हैं वैसे ही रखो.
It's a formula. So what I do, I will give x here, I will give x square here. So x value and x square value.
Okay, sir. Now in this case, this is forming a loop, so I can understand why Excel will not be able to solve this. But otherwise, if it were not a loop, Excel would still be able to move ahead, right?
I think for that you have to learn macro Excel.
Macros and all, okay.
Macro or micro Excel. That is little advanced level.
Okay.
Excel is such a vast area, Ray. Excel is not simply statistics and operation research. It can many things. Because in function itself you see effects. The all functions, देखो कितना है. The financial, see mathematics and trigonometry, statistics, lookups and reference. So that way lot many things are there in Excel. It is not possible within a day or within a month you can complete it. By practice it will come. When you go to a definite area, you will realize how to use it.
Okay, sir. Sure.
Your question is there because in operation research we are doing here only linear programming problem. What about if non-linear programming problem? है ना? But logic is the same. Here we have everywhere linear. Everywhere we have linear. For example, LPP देखो. See, these are linear function. Isn't it? They all are linear functions.
Yes, sir. Yes.
And they are in decision variable. So linear programming problem, transportation problem, assignment problem, all are on linear functions. Variable and cost, variable and profit, constraints. In LPP also we have constraint, in TP also we have constraint, in AP also we have constraint. This is a family of LPP. Is it okay? Okay. What about others? Everybody has completed? Which machine is idle in question 3? To minimize, which machine is idle? Savi Agarwal.
So machine Z.
Machine?
So machine Z.
Saloni Kejriwal.
We kind of took a
Are,
little.
are you getting the answer? Z is idle?
Yes, sir.
Okay. Rachit Tyagi.
Yes, sir.
Could you get the Z idle?
Yes, sir. Yes, sir.
Very good. Very good. Therefore, a part of operations research technique we have introduced. Attentive. A part of operations research technique is introduced. Now we are going little advanced. I am not going to do most of the work today, but next week point of view. Let me ask you. You have a transportation problem. Any you take, balanced or unbalanced, conditional, kuch bhi ho. If you have a minimizing the transportation cost, along with that, something also required. What is it? Anybody?
Sir, compulsory allocation.
Times.
Listen. See, each unit transportation cost is given to you. And the trucks are taking plenty units from Delhi to Pune, possibly Delhi to Kolkata, Delhi to Jaipur, etc., 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 by road. But along with that, the company is interested something more. What is it?
So the time it takes to actually reach, apart from the cost.
Okay. Further. Further.
Mode of transportation.
Okay. Further.
Distance.
Okay. Further. Further. In company point of view, you think.
Number of drivers required.
Yes. You are thinking only on transportation cost. You think about the company point of view.
So units to be transported.
Why you have to do business?
Profit,
So
sir.
revenue generating.
Profit.
Profit, sir.
So, along with this minimum transportation cost, you are expecting
Maximum profit.
maximum profit. This is called dual TP. Dual means if there is a problem of minimization, definitely for that there is a maximization also. If there is a maximization problem, definitely there will be a minimization problem. Suppose in this example itself I want the maximum profit, what should be given to you?
So profit per delivery.
Correct. Profit per unit, correct na? And somebody said time, mileage, etc., that is taken care of in the cost. By road, it is mileage. So they are looking minimum mileage, then minimum cost. There is minimum mileage, there is minimum cost. Okay. This is what I am going to start today to introduce you. How to do that is in LPP. It is written in your sheet 2. What is a dual LPP? I will explain the steps first and then we talk about an example. We won't get time to solve it. Okay. Yellow color is a given LPP. A given LPP is called primal LPP. A given LPP is called a primal LPP. So the primal LPP says Z equal to 8x1 plus 10x2 plus 5x3. This is to be maximum. Subject to x1 minus x3 less than or equal to 4, in which I don't have x2. 2x1 plus 4x2 less than or equal to 12, in which I don't have x3. Minus x1 minus x2 minus x3 less than or equal to minus 2. 3x1 plus 2x2 minus x3 less than or equal to 8. Minus 3x1 minus 2x2 plus x3 less than or equal to minus 8. 4 constraints. This is similar to that we have done in our regular class. So what is dual? That is what I am explaining in blue.
Sir, you are not sharing your screen, I think.
Okay, good. I will share. Visible?
Yes, sir, now it's visible.
Yes, sir.
So the yellow color is your original LPP like what we do in the class. Then blue is called dual LPP. No matter primal LPP or dual LPP, the first step will be variables. So in primal I have 3 variables, but dual, number of variables are equal to number of constraints. This is the first rule. Number of variables equal to number of constraints in the primal. That is the first step. So in my example, I have y1, y2, y3, y4, y5. And primal is maximum, so dual will be minimum.
So, sorry to interrupt, but what's primal and what's dual? I didn't understand that.
If the primal problem is of a maximization type, dual will be minimization. Okay, I told you TP. Cost if I want to minimize, at the same time I want to maximize the profit. So for every transportation problem, every LPP, along with the primal LPP, there is a dual LPP. So I told you the first LPP is primal, yellow. So dual will be minimization. In what? Constraints. Minimize the resources. Which are they? 4y1, 12y2, minus 2y3, 8y4, minus 8y5. Linear combination of a resource, maybe in hours, maybe in material, maybe in working, man-hour. And constraints are 3 because you have 3 variable x1, x2, x3 in primal. First constraint, x1 ka coefficient 1 time y1, 2 time y2, minus 1 time y3, 3 times y4 and minus 3 times y5. Greater than or equal to 8 is the first constraint. Next, 0 into y1, then 4 into y2, minus 1 into y3, 2 into y4, minus 2 into y5 greater than or equal to 10. And minus 1 into 0 into y2, minus 1 into y3, minus 1 into y4, and 1 into y5 is greater than or equal to 5. So number of constraints in dual same as number of variables in primal. This is the rule. Written in your sheet. In dual, LPP objective function is minimum in this example. Number 2, if the primal LPP make all the constraints either less than or equal to type or greater than or equal to type. Example is shown. In dual, number of variables is equal to number of constraints. y1, y2, y3, y4, y5 in dual LPP is our variable. Write down dual LPP. And once you have written this LPP, you can solve the primal, you can solve the dual. Okay, next week I am doing one example. Next week I will be going to do example. Anybody follow the writing of both primal and LPP? But in your situation, you will be having only one. From there, you have to write a dual. Simple hai. So what is the variable number corresponding to dual and LPP? What is the relation between number of variables in dual? How many variables you will decide?
The number of constraints of primal.
Correct. Okay. Number of constraints in dual. Number of constraints in dual, how do you do?
So number of variables in the dual?
Look in the, you can see on the screen, how many variables in primal?
5.
How many variables in the primal?
3.
How many constraints
sir.
in dual?
3.
How many variables in dual?
5, sir, 5.
So 5.
How many constraints in primal?
5.
That is the logic. Dual of dual LPP, what is it?
The primal cell.
Dual of dual LPP, what is it?
The original primal base.
What is the name of it? Dual of dual LPP. अरे ब्लू में लिखा है ड्यूअल एलपीपी, उसका एक बार ड्यूअल लिखने में क्या होगा?
The primary.
प्राइमल. बेस्ट 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 बेस्ट. Best. So, if I know the answer of primal, I should know the answer of dual. Let us check whether we have this in solver box. Let us just verify whether we have that in the solver box. No, it is not directly given, but we can do. When we come there, we will do. Okay. So, what I simply say, given an LPP, I can definitely write dual LPP. And once I write a dual LPP, both I can solve. I am going to do this example in the next class. Now, let us look how this will help in real problem. Attentive. A firm is engaged in producing two products P and Q. Each of the P require 2 kilogram of raw material, 4 labor hours. Q requires 3 kilogram and 3 hours respectively. Resources. Available material is 60 kilogram, hours 96. Profit is 40 rupee per one and 35 rupee for 1 PQ. We write an LPP. We have written black. Maximum profit equal to 40x plus 35y. Subject to material will be 2x plus 3y kilogram, not more than 60 kilogram. 4x plus 3y is the total time, not more than 96 hours. So what it will be dual here? Before you write a dual, what you are expecting as a dual here? Objective function is profit. Constraints are material and hours. Anybody? What can be dual possible? Don't write LPP. Tell me what can be the meaning of dual here.
So minimizing cost.
And material as well as labor. Minimize the materials used and the hours. So how many variables I have?
3.
How 3?
2.
2. One is related to
Material.
and the other is related to
Labor.
correct. So the objective function will be per unit how much will be the cost involved for material, per unit hours, I mean how much you are charging for man. That has to be minimized. Expenditure should be minimum. usage should be minimum. How many of you follow? Any doubt? But the cost should not be below profit. So 2u plus 4v definitely greater than or equal to 40. 3u plus 3v greater than or equal to 35. This is what LPP. Just opposite to LPP primal, we are writing dual. Just we are dealing with primal and dual. So this one example I will show you now because only two. Okay, let me work now. LPP sheet itself I took. I give the headline primal LPP. And somewhere here I will write dual LPP. Now here I have maximum profit. Here I will be talking about minimum. Say W. So for primal LPP, I have X and Y. And for dual LPP, I have U and V. And the values are given as a profit. 40 and 35. 40 and 35. And here time is given 60 and 95. So my Z value initially equal to, or before that, values. 0 and 0, 0 and 0. Because initially I don't know them. Now we have maximum Z. And here also minimum W. So the linear combination we used to do, remember, equal to value of X multiplied by 40 plus value of Y multiplied by 30. I don't know initially. Same way here. Equal to value of U multiplied by that of 60 plus value of V multiplied by 95. Now constraint here will be material and hours. Constant here will be cost or material, cost or hours. First, two x plus 3y equal to 2 multiplied by x plus 3 multiplied by y is not more than 60 kilogram. Next, equal to 4x plus 3y. Four multiplied by x plus 3 multiplied by y is not more than 96 hours. Same way here cost material. U and V. Check. 2U plus 4V. 2 multiplied by U value plus 4 multiplied by V value should not be less than per unit cost 40. Next, 3U plus 3V. 3 multiplied by U plus 3 multiplied by V, definitely not more than less than 95. Let us see how the answer become. Primal. Objective function will be maximum Z. Cells are X and Y. Constraints both are less than or equal to, so I can give at a time. Solve it. 1000. Go to our next one. This one. Minimize the variable cell UV and condition greater than or equal to okay. Solve it. Is it possible now without hours? You have solved the LPP. So according to the solution, minimum expenditure involved 1900 rupees, and for that much expenditure you are getting 1000 rupees as the profit, 18 and 8. But this is non-integer, so I want to make that as integer. $32 and V. According to our mathematical problem, this is correct. But we have V. That means it explains the labor hours are not at all utilized for the cost. Labor hours cost are not at all utilized. Anyhow, okay, this is a problem. But real life it is not possible. We will get the value of V. I just explained you how to solve it. So such work we are going to do later on. But you have to know how to write primal LPP and dual LPP. Now, another part also I am going to do along with it is called sensitivity analysis. Sensitivity analysis deals with finding out the amount by which we can change the input data for the output in our linear programming model to remain comparatively unchanged. This helps us in determining sensitivity of the data we supply for the problem. You may not be able to understand this. I will explain some other way. Imagine. Attentive, imagine. I am taking one course in an institute. They told me 30 hours is allowed. And 30 hours is fixed. But in between, while taking the classes, I may not be able to engage in a few sessions. So what is the next step? Anybody?
Sir, you can always reschedule to some different date.
Yeah. But first I will calculate how many hours I could not take, correct now?
Yes, sir.
Therefore, this 30 is a fixed number in an interval. Sometimes the syllabus can get over below 30 hours. Sometimes the syllabus can get over above 30 hours. So the time in which the syllabus completed by means of a two numbers. So what is sensitivity analysis says? Sensitivity analysis says, even if you got the answer, will there be any alterations without affecting your optimum? That is what it asks. We have seen that in Choco example, biscuit example, day 1. In this first example, we have done it. That is what I am going to repeat in the next class. Without changing the optimum solution, can we have modifications on constraints? Can we have some other possibilities? It is there in your.
Sir,
Yes.
is it does it concern the constraints, or is it
Correct.
about the different combinations of the allocation?
Variables.
So it's basically finding out different combinations of our allocations.
बराबर है.
Okay.
100% correct.
Okay, sir. Thank you.
So let me show you a little bit of that. Our example, Choco example. Where that has gone. My objective function is maximum and variables are x and y. Constraints are both less than or equal to. This is the answer I got. Then what is sensitivity analysis? See solver. Along with it, if I go for option, in solver it is asking answer, sensitivity analysis and limits. Say limits. I got the limits. Upper limit can be 2. Lower limit, upper limit for x will be 2. Upper limit of y will be 3. To get 27, here we don't have any lower limit. Finished. What does it mean? If I change my limits value 2 and 3, objective value also will change. Let us do sensitivity analysis. It explains you. In that, allowable increase can be 1 unit. Allowable decrease can be 1 unit. That means no possibility of change. But for milk, allowable increase can be 3. Decrease can be 2. So 2 to 3 you can change if you want that of milk. Maybe you are confused. When we do example later on, I will explain you how these numbers help us without affecting the solution. Change your combinations of x, decision variable. So, once you complete this, many ways you can work on LPP. In short, I can say alternative type of allocations without affecting your objective function. You might have given order for material, but same material you may not get. You may get some different material. Accordingly, the constraint will change. So this type of work is the one we are going to do in our next week class. Easy, very easy. I will help you. So, Any question to you? Anjali Garg.
Yes, sir.
Is it today class different from earlier classes?
Sir, can you repeat?
Is it the today's class different from earlier days classes?
Hello?
Okay, do you follow the last work I introduced?
Yes, sir.
Okay. Cherry Chabra,
Yes, sir.
how do you find the last introduction?
Sir, it is very interesting.
Okay.
Something new
But
to
still
learn.
we have to work on example to make you about what is dual and sensitivity analysis.
Yes, sir.
Okay.
I know the how to solve primal. I understood that from CT, but dual is something that I want to
Okay.
learn more about.
Okay, we do. Gaurav Kadam,
Yes, sir.
do you follow today's class?
Yes, sir.
Explain. Explain. Gaurav Kadam. Manvi Kukrecha. Manvi Kukrecha. Okay. Prasoon Sharma. Prasoon Sharma. Pratik Maheshwari.
Yes, sir.
Do you follow today's class?
Yes, sir.
Explain your understanding. Explain what you understood.
Not exactly I understood, but yes.
Okay, try. Okay, revise and come for next class. Okay, first I will ask you questions. Pratik.
Okay, sir. Okay, sir.
Sharanya Bhattacharya. Smithveer.
Yes, sir.
How do you find the class today?
Sir, the class was good today.
Do you follow little bit of that introduction dual?
Yes, I follow. I understood the primal part. Dual is basically minimizing all the cost and minimizing the cost part.
Okay. Suppose if primary is minimum, then dual will be?
Opposite of it, sir.
Correct. So what is the dual of dual?
It will be the primal, sir.
Very good. What is your understanding of sensitivity analysis ka objective?
Sir, its objective is that we can change certain variables without changing the objective value. So
Perfect. So how the table, that's what I have to explain you in the next class. Very good.
Yes, sir. Thank you.
Varun Bajaj.
Yes, sir.
Do you follow today's class?
Yes, sir.
Explain.
So we started with the assignment problems, which is somewhat similar to the transportation problem.
Yes.
And then we did the primal and the dual part.
Yes.
Yes. And then the sensitivity analysis, like if we can increase the inputs or see the impact on the price.
What is the difference between transportation problem and assignment problem?
So in the assignment problem, today we dealt with the classic examples of machines and the worker shifts. So I think it will take time for me.
Okay, revise and come prepared, okay?
Yes, sir.
Anjali Garg. Okay, na class? Anjali Garg. Ashwini Digole.
Yes, sir.
Yeah, do you follow what the class today?
Yes, sir.
Explain.
Sir, first we have done with assignment problem.
Yes.
Then primal and dual.
Yes.
And last we have done with sensitivity analysis.
Okay. What is the difference between TP and AP?
In transportation problem, we have seen sources and their destination delivery destination. And in assignment problem, we have seen workers distribution, work distribution.
Okay. Good.
Thank you, sir.
So, any more questions today? Anybody? Doubt, difficulties? Okay. So, next week I will be mostly completing operations research. And week after next is the last week we get before the test. And you have to ask and get it clear everything at that time. Because after 20th they scheduled the exam, but which date I don't know. So well attentive for every work that we have done in operation research for periodic test 3 and prepare the entire syllabus for your final exam in the March 8. Everyone has to have the sheet with you. Completely sheet I have given the working style. In final exam you are working with R as well as Excel. It is not MCQ, actual work. Okay, see you then. Goodbye. Come prepared for next class.
Thank you, sir.
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 Thank you, sir.